Good afternoon, students. I come to you this Saturday morning about 12 o'clock from beautiful Sperry, Oklahoma in my kitchen. Today we are going to go over the beginnings of some triangulation that we're going to be doing at the end of this year. We'll have some fittings and then we'll start there next year. If you guys are in my class, that's kind of where we start at. But the first thing we want to do is I want to go over the Pythagoras theorem. Pythagoras was a mathematician born in ancient Greek in 535 BC. He was also a philosopher and taught Plato, Aristotle, and all the great philosophers back from the ancient Greek area. He was influential in their lives and in their endeavors that they did. Basically, what he's done is he figured out some laws for a right triangle. What a right triangle is, I've got one drawn here. It would be a three-sided polygon that has a square side on it. Anytime you see this little symbol right here, it tells you that that's a 90-degree angle. So this theorem, these laws of math, are applied to the right triangle. So in this case, this is a 30, 60, 90 degrees. This would be a 60. This would be a 30. So what he come up with, the Pythagorean theorem, basically means that a squared plus b squared equals c squared. Very simply, I take this side. If this was like 6 inches, I would square that. If this was 8, I'd square that. Add these two together and then take the square root of that, and that would be what this side would be. Where this is important is when we do transitions, anything that does not have a straight side, as the line moves in or the side moves in, it gets longer. And you can figure that up through this math equation here to give you the stretch outs of your sides. So that being said, what we're going to do here, I'm going to give you some problems on how to figure these out, and we'll do a couple practice problems using a calculator from your telephone. Excuse me. I know most of you guys, everybody should have a telephone or cell phone that they can use the calculator function on it as one of your apps that will be able to be really handy for using on these. One other thing on this triangle that you might want to know is this would be considered the base, this would be considered the height, and this is called the hypotenuse. So I'm going to write those on here. Hoping those are spelt right. I don't think that is. It doesn't look right. But anyways, that's the parts of the triangle. So the base and the height, anytime you have, and these two are interchangeable. You could call this the base if you flip this up and the other height. But the main thing you got to know is the long side of that triangle is called the hypotenuse. And this is what this formula helps you to solve for, which would be in this picture of this transition that I've got down below, this right here would be a hypotenuse, because if you took this line and you brought it down so that it's squared to the base, that would be a triangle. Okay, same way with this one. Squared it down, you'd have a square corner, and that's how we figure out that stretch out of that side there. Okay, so going with this a squared plus b squared equals c squared. We're going to fill in some numbers here. This particular fitting here, they've got what they call a 3-4-5, which is used a lot in carpentry and a lot of different things for doing slabs and different things. And we'll get into that a little bit later, but let's just use this, and let's put this as a 3 inches, this at 4 inches, okay? And then we're going to figure out what this long side is. So what square means is you multiply it by itself. So 2 squared would be 2 times 2, which would be 4. 3 squared would be 3 times 3, which would equal 9. 4 squared would be obviously 4 times 4 equals 16. So with that being said, want to go to your cell phones, go to your calculator app, and I had it in the calculator app. And there's 2 different modes of it. If you take it like that, you get a very simple calculator. If you turn it over to the side, you end up with a scientific calculator. Over here on my particular phone, you'll see where it says x squared. That means whatever number it is would be squared. You also down here have a square root, which is the button that looks like this. And mine has so this equals square root. And what that means is whatever number divided by itself equals that number. That equals squared. Okay? So when we do this, in this particular case here, we'd say 3 times 3. So on my calculator, go to clear, I'm going to push 3 squared plus, in this case, 4 squared equals 11. And then we want to figure out what the square root is. So we got this squared plus this squared, so it would equal this. So if we hit the square root of these two, then we'd end up with C. So I hit square root, and that's incorrect. So you get 3 squared plus 4 squared equals 25, and then we're going to hit the square root of that, would be 5. Okay, so this is the 0345 triangle. It's used, any derivative of 3, you could get a square corner from that. So if you're laying something in the floor, you could have 3 foot by 4 foot by 5 foot, will give you a square corner. It's pretty handy when you go into doing buildings or something like that, when you're laying out a slab or trying to figure out a big, long square corner. We could use derivatives of this. We could say 3, so you could use a 6, 8, and then you're going to have a right triangle with that also. So to use this thing backwards, so when we do a squared, in this case would be written down like this, would be 3 squared plus 4 squared equals the hypotenuse, which would be the square root of 5. So in this case, that would be 3 times 3 is 9, plus 4 times 4 would be 16, equals 25. And then the square root of 25, and that's the way it would be written, equals 5. Okay? So that would be that. So let's do, we can do that backwards. We can say, okay, we don't have, we have the hypotenuse here, so we had 25, so we would say the square root of 25 minus, in this case, this was A, this was B, and this was actually C. So in this case, this is C minus A, which would be 9, equals 16. Okay? So a little confusing. Once you get used to doing this, it'll come really easy to you. So that being said, we'll do one more of these, and then I'm going to give you guys some problems to solve. Let's say this was, we're going to figure this one out again. This is going to be 5.5 inches. Let's say that this is 7.3 inches. And we want to solve for that triangle. Okay? So what we would do, again with the calculator, so A in this case would be A squared plus B squared equals C squared. So in this case A, so we're going to take .5. So I'm going to go 5.5. We're going to square x2 equals 30 1/4. So in this case that'd be 30.25 plus 7.3 squared. So I'm going to go ahead and clear that and do that single process. 7.3 squared equals 53.29 plus, we're going to add these two together, 83.54. So that's going to give you what those all add up to be, but we want to hit the square root of that. So that would be that symbol right here, 83.5, the square root of that is going to be 9.14 inches. So that would equal, in this case, with these numbers here, 5.5, 3.3, and I'm going to circle, that would make this 9.14 inches. Okay? So that solves these, how to figure these triangles. Now we're going to bring this into using it for our laying out our fittings and doing our slope sides of our transitions or anything that has a slope side. So solving for these two, it's a center tapered. This is going to be a transition. We're not going to show you the depth of it right now, but in this case we'll just say this is a 4x4 and let's call this 8x4 for simplicity reasons. And the fitting is going to be 7 inches long. Okay. This is going to be a weld fitting that we're going to make out of 1/8 inch, so we'll have no connectors or no seams on it. So in this case here, so we got 8 inches. So we got two sides of the triangle right now. We know what the height is, which would be, in this case, would be that. And we know what the base is. Even though it's upside down, that's going to be 2 inches. So using the Pythagoras theorem, A squared plus B squared is going to be equal C squared. So what we're trying to figure out is how long this slope is on this side. So if we're using that, this here would be A, this here would be the portion of B, and then the slope side would be the portion of C. Okay, so let's figure that out. So over here on the triangle, so we got 2, which is A squared is going to be 4 inches. I can do that one in my head. Plus 7 squared would be 7 times 7 equals 49. So that's 49 inches. We add those two equals 53 inches. Okay, so this 53 is these two added together, but I want to get the square root of that. So I take 53 on my calculator. Turn it to the scientific side. I'm going to clear that one. So 53, and then I'm going to hit the square root, which is this symbol right here, is going to equal 7.28 inches. So that distance from there to there on that slope is 7.28 inches. Notice, since this is on a slope, notice that it's almost a little more than 1/4 of an inch longer than the height to make that piece there. So whenever we would do the stretch out of that, we would make this piece 7.28 inches. When we take it and we rock it over to hit 7 inches, then it fits up pretty nice. That being said, I know it's a little confusing. This is kind of hard to do from a remote. I'm going to give you guys some problems. If you have any trouble with it, I think you can Google it. This is some basic geometry / trigonometry. We learned this basically in about 9th grade of junior high whenever I was growing up. They probably learn it in about 6th grade now. But anyways, it sounds complicated. It's really not. You can enter any of these numbers, and essentially what we're wanting to try to do is figure out the slope sides of our transitions. When we get into laying out some the next thing I think we're going to do next week, we're going to lay out a pair of pants that has a couple slope sides to show you that this 7.28 inches, we done it mathematically. I did draw this thing to square, and you can see, we'll do it from this end, you can see that that is going to be right there. You can see that it actually hits up just a little bit more than 7.25 inches. Okay, as you can see, that distance there is right at 7. As we slope that down, it went to 7.25. Okay, now what that does, it saves you from having to lay it out and then put a tape measure on it every time. We can do it mathematically. So that's it. Hope you guys are staying healthy. Make sure you keep cleaning your hands, practicing your social distancing, and be safe, and take care of yourself. Thanks.